well, darn it, my finger hit the pause button. I'm not going back and redoing it, but I wanted to go to 203, number 19, because this is talking about the flip over the y-axis. So why didn't you see a difference between number 8 and its parent graph and number 16 and its parent graph, but you do see a difference in number 18's graph? Number 8 had a negative x inside the function, and it just laid right on top of itself, so you didn't see any difference. The same thing happened in number 16. Well, both 8 and 16 have symmetry over the y-axis. It looks exactly the same on both sides. So when you transform the function, you can't see a difference. However, in number 18, there is not symmetry over the y-axis. So you're going to see this piece get reflected in this direction. So when there is no symmetry, so number 18 has no y-axis symmetry, so you see the transformation is what you should have put in talking about number 19. So you might want to add, when it's talking about the y-axis symmetry, that you will only see the transformation in graphs that don't have y-axis symmetry. So x squared obviously is symmetrical, so you're not going to see the physical transformation. And then the last type of transformation seems to be a little bit confusing to students, whether it's getting taller, shorter, is it stretching, shrinking? How do I refer to that? I always refer to it as vertical. So a vertical stretch means it's getting taller than the parent function by multiplying it by 2 or 3 or 4 times as much. A vertical shrink means it's smaller than the original function, so 1/4 as tall. So those are your actual transformation rules. So this page is just us practicing again, writing those functions. So I chose x cubed and I chose absolute value of x because this one already had x squared on it. So I wanted to just practice writing those transformations again. And then you are going to do the back page and identify what type of transformation has occurred. And I will do a couple of them with you to get you started. So how would I show that x cubed is going up? So I might write y equals x cubed plus 8, right? That would move it up 8 on the y-axis. So you're adding a number outside of the function. What about absolute value? So it's kind of the same. Y equals the absolute value of x plus 8. So the function comes first, and then you're adding a number outside the function. What about if we wanted to shift down? So what about y equals x cubed minus 2? That would shift it down 2 units, or absolute value of x minus 2. The vertical shifts up and down seem to be the easiest because it's what you would think would happen. You write the whole function and then adding 8. You write the whole function, subtracting 2. Rights and lefts get a little bit more confusing, but remember, if you want to go to the right, it's a minus sign. You're shifting it to the right by changing the x-intercept. So like, let's say we've got parenthesis, I'm going to the right by 1, and then I'm cubing the function. So that would take the function and move it right 1 unit. And if I wanted to do the same for absolute value, I can move it right 1 unit. All right, how far to the left should we shift? So this time let's shift, how about 5? X plus 5 cubed. So that would shift me to the left by 5. Or absolute value of x plus 5 would shift absolute value left 5. So you just put whatever function you're working on. The transformation rule is the same. All right, Now reflecting over the x-axis, that's when you put the negative sign in front of the whole function. So for example, we'll write y equals negative x cubed, or y equals negative absolute value of x. So that's in front of the function. If you want to reflect it over the y-axis, you actually write the negative sign inside the function, and then I would either cube it, or in this case, I'm taking the absolute value of it. Remember, this one, you're actually not going to see any transformation because this was symmetrical over the y-axis. And this one you will see the reflection, but these two are actually going to come out the same. And then what about stretching our graph? So if I want to make it taller, I could say 2x cubed, or 2 times the absolute value of x. If I want to make it less tall, I could say 1/4 x cubed, or 1/4 absolute value of x. Let me ask you a quick question. What do you think 5/4 x cubed, what do you think would happen to it? So here the fraction is less than 1, so it's smaller than the parent function. This is a fraction, but it's actually bigger than 1. It's 1 1/4 times as tall. So this is actually going to stretch. So it's not just that it is a fraction, it has to be a fraction that's less than 1. If it's a fraction bigger than 1, it's going to make it actually stretch it steeper. All right, so now we're going to state the transformation for each of these functions. And if you forget, look back at your notes, plug it into the calculator. I am going to look at 1, 5, 1 and 5, I think are good. All right, so this is a quadratic function. The two changes being made are this 4 and this 6. So what are those actually doing? The 4 is multiplying the function by 4. So it's a vertical stretch by 4. And this is outside the function, so it's going to move me up 6. We haven't talked a lot about exponential equations yet. We're going to this year. So this plus 7 is up in the exponent with x. So that's going to be a left or right transformation. Over here, here's an exponential function, and this is not in the exponent. So this is going to be up or down. So this is going to be, because it's a plus sign, it's actually going to move me to the left by 7. So it's kind of like pretending this is inside a parenthesis where everything is kind of backwards. So the page that you need to send me for today is this guided practice sheet. And good luck.